Hello students, welcome to CalmScienceClasses.net. Teacher Mercy is here, and today we are doing physics. Our topic is linear motion and we are in Form 3 work. By the end of this lesson, our learners should be able to 1. Define distance and state its SI unit. 2. Define displacement and state its SI unit. 3. Give the difference between distance and displacement. And finally, demonstrate an understanding of distance and displacement. Distance is defined as a measure of length between 2 points, or the total length covered. So here we have the green dot and we have the black dot. The length between the green and the black dot will be distance. The SI unit of distance is the meter. Since distance is a length, then the SI unit of distance becomes meter. Distance is a scalar quantity. It only depends on the magnitude. The direction of the path is not taken into account. The total distance would be 40 meters plus 30 meters, and therefore our total distance will be 70 meters. However, if we were to get displacement, then the displacement would be the diagonal. How then do we define displacement? Displacement is defined as the distance moved by a body in a specified direction. Displacement is always the shortest distance from the initial to the final position. Being a distance also, the displacement will be a length whose SI unit will be the meter. And it is a vector quantity because it is described by both magnitude and direction. So what would be our displacement in this case? So our displacement would be the square root of 40 square plus 30 square. Let us understand this displacement better. Here, our distance from A to B is 100 meters. But because the distance is a measurement of length between 2 points and displacement has direction, then our body moves from A to B due east through 100 meters. So our displacement will be 100 meters due east. What if our body moved from point A to point B and back to the middle? What will be our distance? Then the total distance covered will be 50 meters, 0. Our body moves from 0A to 100 meters B and then back to 50 meters in the middle. So our total distance will be 100 meters plus 50 meters, and therefore our total distance is 150 meters. However, our displacement will be A to B considered positive, so that is positive 100 meters, and then the reverse direction B to 50 meters east, then that is negative 50, and our total displacement will be 50 meters due east. Consider this taxi driver moving from point A to point B and back to point A. If the distance was 100 meters from A to B, then the total distance is 200 meters. However, our displacement would be 100 meters to B and 100 meters back to A, and therefore our total displacement will be 0. There will be no change in the direction, or there will be no change in the location of our taxi driver. So displacement, much as it has the same unit as distance, the SI unit being meter, the distance is a scalar quantity, while the displacement is a vector quantity. So what is our total distance here? 40 plus 30, 70. What is our total displacement here? Our total displacement, 40 squared plus 30 squared, that is 2,500. And then we square root, and our answer will be 50 meters. It will be 50 meters due northeast from our initial position to the final position. So this is the displacement. Thank you. It was a pleasure having you. Let's meet in our next lesson, where we shall be looking at the difference between speed and velocity.